In this last part of the classic Revision 4C build, we're going to install the LEDs and the final onboard components. The components that we have here are some 1K resistors, so 5 1K resistors, one 10K resistor, 3 2N7000s, an MPSA 42 and some header pins. And then what we'll do is we'll connect it all up and we'll check that it works. So the first thing to do is on the 2N7000s, you notice that the leads are all straight at the moment, but on the board you'll notice that they're in a triangle, so we have to bend the center lead back, and Q3, Q4 and Q5. Q3, Q4 and Q5 are the 2N7000s. Q3, Q4. Don't put these so close to the board, they're a little bit heat sensitive, so it's best just to give them some slightly longer leads. Q3, Q4, Q5, and we'll align those to make them all in line, and then we'll solder, as usual, just one leg in place just to make sure that we're in the right way. Okay, so that's good. And then, to make the final pin easier, let's trim up the ones we've done. Make sure you get all of the offcuts off the board and out of your working area. Otherwise you'll end up zapping something. Trim also the last pin up. The last TO92 is the MPSA 42. It's just written on there A42, and this goes in the space of Q6. The reason that this is an MPSA 42, not a 2N7000, is that for the tick LEDs you can also install neons if you wish. So the MPSA 42 is able to handle the voltage that a neon requires, and the 2N7000 is not able to do that. So we give you the option here is if you want to install neons as the tick as the separator, you can do that. So now what we're going to do is we're going to install the 1K resistors, and that's R23, R19, R20, R21 and R22. Leave R12 and R13 unpopulated. They are for the unpopulated digit circuits. So the unpopulated, anodes. Make sure you don't mess up your components here. Make sure you get the 1K resistors going in here and not the 10K. So all 5 down here. Let me balance that on there while I'm putting these in. Okay. these. These all look good. So, and again, the usual note here, don't, you know what we'll do is we'll put the header in now to save us blocking up the holes, blocking up the pins for it. That would just be silly. We might as well do this now, and then we can't get anything wrong. Okay, that looks to be in well. So let's do the rest of the header pins. Now we can do the resistors. The remaining resistor leads with no risk of filling up pins that we didn't need to fill up. Okay. Okay. Now, last component is R11, which goes in here. And this is the pull-up resistor for the light-dependent resistor. So this clock has linear dimming, so that means it doesn't just go bright or dark. It adapts to the to how much light there is in the room, and it's a much nicer effect than it just suddenly going bam, bright or dim. And this makes the clock a lot easier on the eyes as well. Okay, final components here. So the front panel header, and the header for the time provider, so either the Wi-Fi time provider or the RTC, the real-time clock module. That didn't go in straight, so we'll straighten that up. Also straighten that one up while we're at it. We'll complete the headers, and that is basically the clock. There we go. So we'll check to make sure that the tick LED circuit and the rest of the circuit is working. So let's connect it all up again. And these are my test harnesses, but you can do a similar thing when you come to wire it all up. And there's also a connector on here So there's a connector on here which allows me to plug in my few RGB LEDs and the separator LEDs. Now I've got these wired up in series, so I've just got them coming in from V in into one, series into the other, and then onto the socket. That's fine. So we pop that on. If I just remember rightly which is the order, let me check the pin out. So it is on the connector, it is red, green, blue, and then the separators. So that should be fine. So let's lay things out and let's zoom out a little so you can maybe see better, and let's see what happens. So we turn on. So red, green, blue. The reason that only the center one is coming on is because these other two LEDs have got a wiring problem. You can see what it's doing is it's cycling through the numbers here and it's cycling through the LEDs here. This is testing all of them. So that is all working. One other thing to notice is that the tubes actually go out after a little while. So if I power off, back on again, the tubes will light up, but they'll only run for 60 seconds and then they'll turn off. This is a safety feature and it's intended. So now what I'm going to do is I'm just going to plug onto this connector here, so the switch and the LDR, and then we can set it into test mode. So now we're going to go through the startup sequence of the new clock. So you should be able to see everything here. There's the module itself, the tubes, the backlights, the LDR and the switch. And then if we power it on, we'll see it goes into its test routine. And it's going to continue like that for a minute, and then it will turn off, but we're going to interrupt it before that. And the way we get it out of test mode into calibration mode is we wait until it says 8888, and we press the switch. And now what you'll see is that it calibrates the high voltage generator. So it's counting up to get the pulse width, and then it works with that, then it goes into the final setup. You only have to do this once. Once this is done, it's done. So there it shows us the version, and there's the time. So now, one nice thing about this is the light dependent resistor. So if we cover it up, the display goes dim, and if we let it see the light again, then it brightens the display. And this is what I was saying about the progressive dimming. So it doesn't just go dark and light, it actually adapts as it goes towards dusk or twilight. And then we can have a look at the different modes. So there's 12, 35, and there's 35 and 36 seconds. And then you can step through the different modes there. So that's all in the manual. And that's it. We have one fully working clock.